guys, Gary here with Gen VFX. Nice to be back. Sorry about the time it's taken me to be back, but I've had lots of things that have been getting, not in the way, but becoming more of an issue that needs to be done first of all, work-wise, life-wise, stuff-wise. You know how this goes, it's all everything-wise. But back now, going to do a tutorial. It's a bit of a mathy one, actually, and I will go over it and explain it properly because, well, it's After Effects, and it's motion graphics, but it's maths. And this is the sort of thing that when I started doing this kind of thing, I didn't want to know that maths was involved. I'm a creative. Why do I want to do anything with maths? Because it saves so much time. But before I do that, a while ago, I did a review for Lenovo of their P620, which was this beautiful, massive box that was basically like 10 computers, 20 computers all shoved into this one box. And it was fast, and it was furious, and it was fabulous. And I absolutely loved it. And then recently, James Clark, again, the guy who works in terms of the sales and stuff, said, do you want to have a look at something else? And I went, yeah, I'd love to. What can you send me now? And he sent me over a laptop. And my first thought was, it's a laptop. I mean, it's just a laptop, right? Can't be that great. So stupid. Wait and I'll show you. This here is a Lenovo ThinkPad. Now, anyone who knows about Lenovo is they took over doing the ThinkPads a while ago. And if you know anything about the ThinkPads, normally you think of them more as kind of like a bit of a brick. This, I must endeavour to point out, is not a brick. It is still quite nice profile, despite the fact that it is still quite thick. But then can I just say, you basically get bang for your buck in this thing. It's not the lightest machine in the world by any stretch of the imagination, but as you can tell by the exhaust ports on the back, it's a bit of a beautiful beast. If I just open up the lid here, very carefully, open up the screen, you can see the clarity of that thing. I mean, I've got no lights coming on the front of us. There's just a bit of light coming in from outside because I face the window in my office. This is just a glorious piece of kit. It's basically the Lenovo ThinkPad P16 2nd generation in Storm Grey. And it's got an i7-13850 HD Intel core inside, which basically works out as 20 cores. It's stunning. Also inside of this, by the way, is an NVIDIA Ada Lovelace RTX 5000 16GB graphics card. It renders equally as fast as several desktops that I know that I've worked with. It's maybe a tiny bit noisy, but to be fair, it's working really hard. So as well as it's got like its webcam, its Bluetooth, its Wi-Fi, backlit keyboard, it's also got several USBs, it's got a Thunderbolt drive, a USB-C drive port, and it has a memory card slot for all those lovely times when you take your big one out of your camera and you shove it in, or you got like your adapter and you shove that in and you get all your pictures off. The one thing it doesn't have, which kind of surprised me, but then I suppose didn't, is it doesn't have a local area network port. So I'm used to having somewhere plug it in a LAN cable. So that's always been a bit of sort of like, why not for me? HDMI out, great, love that, but still, where's my LAN port? I want my LAN port. But most places where you work these days, you don't normally connect directly into a LAN. You're normally working on a wireless network anyway, so that works absolutely fine. As for working fine, it blisters. I mean, you know, my fingers don't move fast enough to actually work that thing these days. It's beautiful, it's fast, it's quick, and it's fabulous. And Lenovo did an absolutely blistering job of taking the ThinkPad range, which I'm trying to remember who it was. It wasn't. Who was it who did the ThinkPad range? It'll come to me. It'll come to me. It was IBM. So originally the range was owned by IBM, the ThinkPad range, and they produced what essentially was a solid machine that was, you know, a little bit of a brick, but it did exactly what was required. What Lenovo have done is they've taken that IBM brick and they finessed it somewhat, I think, when you look at it, you know. And as a rule, the IBM ThinkPads didn't have a number pad on the side. At least I don't think they did. It was quite rare. Whereas it seems that even though they're still doing the ones without a number pad on the side because you've got numbers at the top, Lenovo have actually realised that sometimes people do need particularly a number pad on the side. And if you are using something like 3D, like Blender, for example, there's a lot of things you use a numeric pad, which basically does not correlate with the numbers on the top of the keyboard. And that happens a lot with other pieces of software, because each key essentially fundamentally is a shortcut that makes you do something that needs to be there. If you don't have that number pad and you sort of like kind of simulate it on the side by running function keys and stuff, it's another button to press, and it can be a little bit confusing. But they've created a beautiful box there, a fabulous machine. I can't thank them enough for allowing me to use this. Want to reiterate, they are not sponsoring me. This thing goes back tomorrow, so I don't want it to go back because I really like using it. But you know, you've got to let these things let it go. I'm not saying anymore, copyright. But nonetheless, despite all of that, it's a beautiful machine. It works really well. Lenovo seem to keep on hitting the note every single time with these things. Every time I use one of their machines, I love it. There is no other way to put it. And every time I have to give one back, my heart dies a little bit on the inside. But I just what I need to do is actually buy one. And if I'm going to buy any laptop, which will probably be the next buy, it will be one of those. Let's just say that machine is an absolute piece of technical genius. Lenovo have been wonderful, allowing me to just look at some of their machines, and you know, it's not difficult to see why they are doing as well as they are, and I hope that carries on to come. Anyway, enough of me going on. Let's get down to the tutorial, and we'll speak to you again in a bit. Okay guys, so here we are in After Effects. Yes, it's not Blender. And this is about showing you how to use mathematics to make your life faster and quicker and more accurate. And the reason I'm using After Effects is because a lot of the things that I want to show you are done in a much more simple manner in Blender, but it's handy to know the mathematics. So what we're going to do basically is, you can see here we've got a kind of a poor man's piston. Okay, so we've got a circle down here which has got a diameter of 200 pixels. We've got a little arm that comes up here that currently is its anchor point is here, and then at the top of that we've got a head, like a piston head, because the idea is I'm going to basically do a whole piston-y kind of thing, just like you would do, say, for a train, or if you are creating a pistons for an engine. Now basically I just want to talk very quickly about how I'm going to animate the arm, and then also how I'm going to animate how the arm points at the piston. Now the reason why I'm doing this quickly first is because I want to get out of the way, because it's maths and a lot of people don't want to hear it, but it actually is literally it's like ticking God mode in After Effects, because you can do things with maths in After Effects that would take you forever to do by hand. So this is the reason why it literally is like God mode in After Effects. Now what we've got here is a circle which, as I said, has got a diameter of 200, and I want to move this arm around it so it looks like it's connected to that circle. Now theoretically I literally could add it as a parent to this, and then as I span that it would spin the arm, but then the arm, if I do that, in fact let's do it and see what I'll show you what I mean. If I parent that to the crank, and let's just move the arm, let's position the arm out here by 100. That's by pressing P to get position up, and then I spin this crank. Let me just see what happens when I rotate this. Does that? It looks more like a Catherine wheel. That's not what we want. What we want to do, instead of doing that, no parenting, is we want this to have whatever position it is currently. I want to add some value to it, so it moves it over to here and over to here over a period of time, or in fact over time, so we can use time as a guide. And then also I want to be able to do this with it and move it up and down. Now in order for this to travel around this, we have to use a cosine and a sine. Now a sine curve basically over time, over values, basically is finding out the point, the height point on this curve over time. So as each degree ticks over, the height is different, but at the top the height is very similar for a while before it speeds up and then goes here again. So that basically gives you that sine wavy sort of shape over time. Now here's the best thing. Sine starts at -1 at 0. If you're using time as a constant, it starts at -1, and by the time it reaches basically what is considered to be 180 degrees, it's gone up to 1.
and by the time it reaches 360 degrees, it's come down to -1 again. So each revolution of this is down and up. So it's 1, 0, -1, 0, 1. And it basically will generate that sine wave over time, constantly. So sine basically comes from checking the height vertically over the degrees of this. Actually, this is the thing, it's not degrees, it's radians. Radians are kind of like, if you imagine a circle goes from 0 to 360 in one turn, this is the thing. Actually, the circumference of a circle, if you note this, is 2 pi r. Okay, so essentially you can say, right, well, if it's 2 pi, then this is 1 pi, and that is another pi. So our radians are calculated using pi. So pi starts at 0, down here it's 3.14159, and then up here it's 6.283 something or other. Okay, so basically 0 pi, half a pi, full pi, pi and a half, 2 pi. So you can, this is what a radians are in relation to degrees. It's the best way to describe it. So radians and degrees basically allow you, degrees give you the angle as it goes all around, radians allow you to do things with triangles. And that's where things get really clever. We'll come back to that in a bit. But, so if we were to, best way to show this really is to actually show it. So what I'm going to do is I'm going to make a new shape layer, just to basically show you what sine looks like. And you can see things appeared in the middle. I'm going to add to it an ellipse. I'm going to make that ellipse pop open the ellipse shape. I'm going to make it just like this, so it's a 20, so it's smaller. Okay, and I'm going to go to position it over here. I'm going to push it all the way over here, and I'm going to put very quickly, I am going to make a very quick expression on this, and this will help to explain it as well. So if you press this time, the little time key vary stopwatch thingy, time vary stopwatch, if you click on that with your finger on Alt, if you click on that once, it creates your keyframe. But if you click on it with Alt key, what that does is it gives you an alternate way of keying. So what I'm going to try and do is explain this in a bit more of an accurate way rather than the way that I did when I was actually recording this. Whenever you click on the time vary button, with Alt, it opens up the expression that is it correct, and then the first thing it shows you is a piece of text which is literally the content of what you clicked. So if you clicked on the position, it will be transform.position. Now you don't have to have transform.position in there. You can change it to the word value, which is actually a lot easier to have because value is basically the same for whichever one you go into. It just says whatever is here. So rather than saying transport.position or transport.rotation, you just say value, and that's invaluable because it's so much easier. What you can then do then is you can then add additional values on top of value. So at the moment what I'm talking about is adding numbers to XY values because we're working in a 2D environment. XY values added to our value because we've got two values, X and Y. If you then add two values, say open square brackets 0, 0, you get your original value that you was in there, which you can adjust, plus an extra offset value. Because the offset value we're going to put in here is going to be using sine and cosine. So we get those lovely waves up and down between -1 and 1, which we can then use to go up and down. So this tiny little dot, which you can see that I'm just filling in now, I'm just going to go in here and I'm going to change the value here so that it actually becomes time. Now when I change the value to time, what that does is it says look at the actual frames and use those to move me forwards. But it's frames divided by 25 because it's time, it's not frame. And we're working in 25 frames per second. So in order to get it to move faster, you multiply time by a value. So I've multiplied time there by 100, and you can see just in the X, it's just going left and right, and it's doing a pretty fine job of actually going in that general direction. Looks like. So I'm going to pop into here, into our expression, and I'm going to do the typical little JavaScript thing, which is put 2 forward slashes there, which allows me to put in a comment. And the comment I'm going to put in here is make variable from sine. That's just so I know what I've got to do. So I'm going to say make a variable y, let's just call it ypos, because it's in the y position. Okay, so ypos, give me, don't do that, equals, and let's say it's math because you have to basically put the math first dot sine. That is a typical JavaScript thing, and then press enter, which gives us a little curly bracket. It's telling me, yeah, ypos is not defined. No, it isn't, but it will be. Ypos equals math sine, and then we're going to put in here time. Okay, so now it's all working. You can just see that. So there we go. Make variable from sine ypos equals math time, and then where I've got here, which I've got math time, I'm going to put in here. Let's just do add to y position over time. Okay, so got my little comment. Make this bit bigger so we can see properly. And where that 0 is, I'm going to change that to ypos. Yep. So now what's happening is you can't really see it. It's really small because it's a really small value. It's going up and down as it's going along. So if let's do this. If I make math dot sine times sine, I'm going to multiply the final result. So let's go like multiply by 100. And now what will happen is it goes, instead of between -1 and 1, which is what sine is, it's now going between -100 and 100. And it's adding those values in that expression right there, ypos. Okay, so now if I press play, there you go, you can see it's now creating a sort of up-down path. Now that's all well and good, we like that, you can see it there. Let's just very quickly put a command on this, an effect on this. If I go down to time, I'm going to put on the echo. If I push this forwards, I'm going to turn off the viewing option so we don't see anything. It's just all command. There you go. So if I do this, you can't really see, but there is a tiny little offset. So if I now move this, you can see it's got this beautiful little shape. So you can already do, some really nice little things, just like creating a trail. Now you notice it gets shorter near the top and it gets longer when it's going down. That's because the angle, as I said, because it's angles of a circle, they're further apart as they're traveling down, and they're closer together when they're at the top and bottom. So if I just very carefully, there we go, if I push this to a bigger value and I do this, there we go. So, and I'll just put a few more of these in so you can see that this actually is creating an ease in, ease out kind of look, because it's traveling up to the top of the circle and then it's traveling down again. So if I didn't actually have that traveling left and right, it would just be going up and down. At the moment, we've just got y position is equal to math sine times 100. I'm going to put another one in here called x position equals math dot cosine, which is just COS. Okay, time, and I'm also going to times that by 100. Okay, so what will happen now is nothing, because I haven't added it to our value at the bottom. So I'm going to change where I've got sine here. Stop. Oops. Let's stop this. Where I've got ypos here in our little expression, and I've got time times 100, I'm going to change that to xpos. Because basically, and you can see immediately what happens, I'm going to reduce the amount of these. Let's put that there like that. Let's even decay it a bit. Yeah, looks pretty nice. Because the cosine, whereas sine starts at -1, it's basically 90 degrees further around the curve where it starts doing the cosine. We've got that math.sine going left to right at an offset of 90 degrees. So what ends up happening is you end up with something that moves in a circle. That's so handy. So you can see how that works there. So what we could do is we can, doesn't have that 100, because it's the same value on each one, we could set that to, let's say, call it rad. Yeah, we can't call it radius because we need to have a value for radius. So let's call it rad on both of those, and it's saying I don't know what that is, so I'm going to make a variable here, and I'm going to go rad equals 100. So there's our radius to 100, and then if I change the value here, it changes it on both the x and the y position. So this is really, really useful. So let's, you can see, can't you, fundamentally the maths are just cool to mess around with. You can do all sorts of things. But if we do this on the arm, so let's just do this. In fact, what we can do here is we can take all of this like this, and I go Control C, and then I will come up here and I'll turn that off, go down to our arm, go into position, Alt click on the arm's position where it is, and then get Control V in here and let go. And you'll see straight away what we've got now is that arm, using exactly the same maths as the other one, is now rotating around our crank. At least it looks like it's rotating around the crank. The crank's not moving at all. Doesn't need to, it's just a circle. If it had detail on it, we could do something with it. So that's now basically doing our circular motion by, not by rotating, but by basically repositioning along a circle. So there's our maths in there with a radius control set in, radius equals 100. What happens if we want to speed it up? Well, here we go. You see, we can just create a variable called speed, and then we can stick that in to make time move faster. So basically, if you multiply time by 2, it happens twice as quickly. That's the kind of thing. So it's like time travel. So SPD, and let's go with that and put that equals 5. And then in the bracket here where we've got time, we'll go multiplied by speed. There we go, it comes up. So now we've got speed equals 5, and then, so it'll make whatever speed value is, make time that much faster. So now if we play this back, there you go. That's a more realistic speed. Well, it's not, it will be like thousands of times faster than that, but at least, you know, it's a bit more pistonish. Well, we're going to use a bit more of this now on the head. So we're going to carry on, because at the moment we've got this Y position, yeah? And we want the Y position of this to be something we can use. So let's click on the head, press P to bring up the position. Let's Alt click on that. And we've got this little whip here. Can you see this? A little whip. So what I can do is I can do this, and I can drag this and connect to the Y position, and it creates us an expression. And it says temp equals this layer arm dot transform dot position, little square brackets, it's got 1. And that's because we dragged it onto the Y. And if you know anything about index numbers start at 0. So if you've got 10 items, the first one will have an index of, or an ID of 0, and the 10th one will have an ID of 9. So if you've got X and Y between 2 square brackets, the X, its identification number is 0, and the Y's identification number is 1. We don't want temp because what it's saying is the X and Y values are both going to be that Y value. So where it says temp in that first one, we change that to 0. So it just does this. But as you can see, again, it basically puts this at 0. So if I play this now, you'll be able to see that the head will move up and down, basically doing that sort of like cosine motion just in the Y. It's not repositioning, it's just doing up and down over time. But it's got it in the wrong place. That is the X position because it's at 0. But we don't want that. We want it to be whatever the value of this is, whatever the positional value is, plus these 2 values. So that's it. We put value, and we go plus, and then we press enter on the keypad, and now you'll see it's like there. But the value it had is basically wrong because it's too low. So we're going to move this up like this, and now we've got that doing that. Now the next thing we've got to do is we've got to make sure that the arm always points, because at the moment the height of it is exactly just past, you can see it's always just past the middle of the piston head. So what we're going to do now is make it so that the arm is always pointing at that head point where the origin is, right there, because that origin point is really important if you're doing something, you want something to aim at something. Now if you look into the maths that exist built in expressions, in theory you should be able to go to the rotation and basically set the rotation of this so it looks at that. In fact, there is, if I go Alt on the rotate, and then I go here, which by the way, this, you can't see this properly. Let me just bring this up temporarily. And I'm going to click on this little square here. Now here you can see, if I click on this, there's lots and lots of little pieces of script. All of this stuff here, there's loads of things that have uses, and then you can change all sorts of things. But then in here, and I'm trying to remember where it is it in here? No, it's not there. Vector math here, it's got look at, from point, and at point. And in my head I should use this. But the problem is it flips, because if you go past a 0 value, it'll go, oh, I'm on a 0 value, and tries to negate it and put it back into a positive value, which is a bit rubbish. But lucky for us, what we have here instead in here is something called math.atan2. So basically, what is an arctangent? Well, it's an inverse tangent, but that still sounds too mathy. So to try and explain it as simply as possible, if you've got 2 points in 2D space, say for example, in this instance, an arm and what it wants to point to, which is a head, you think of those as 2 points of a triangle. And if you have these two distances that go from x and y between those 2 points, you can work out what the difference is between them in x and y. Then you use those two values with an arctan or an atan2 to generate an angle, which essentially is the rotation angle that you want. And that's basically it. So let's get this back to where we can see what we're doing. And I'm going to bring this down here. There we go. So I want this arm, I want its rotation to be the angle between here and that exact point there. So if I give you an idea, if I just rotate this arm, that's what I want it to do. And that says it's 14 degrees. Right, so what I'm going to do is the same as I did before. I'm just going to put here value. So let's leave value there for the time being. I'm going to put a little comment here, and I'm going to get some stuff. So let's call this point at. Why not? Okay. So what we need to do is we need to find out where our target object is. Yeah, that's a target object. So I'm going to create a variable, just call it t. I'm going to say equals, and then I want it to be this layer, the head. So what I'm going to do is going to get to a little whip and just click to do this, just that. So it's t equals this comp.layer head. Okay, so that just gives us the position of where that head is. Now what I need to know is where I am in relation to this. So we can call up our position dead easily in a layer. That layer's position is literally position. Let's call it P for the sake of argument, because it's position, equals, I want to take my position away from the target position. So I put t.position minus position, because that just calls back, as I said, that just calls back my position. Yeah, which is exactly what you want. So now we've got our value of P, which is the distance between our 2 points in both x and y. We can then use those with an arctangent function to generate a small radian angle, which is exactly what we need. So let's create a variable called r. So what we do is we go r equals math.atan2, and yes, I am literally typing this out as I go along. And remember what I said about index numbers? We need the values of P at x and y. But because of the way arctangent works, it needs the y value first, which is the height, and then the x value afterwards, which is the horizontal line. Okay, so we go P square bracket 1, because that's our y value, and then comma, and you go P square bracket 0. Okay. What we're going to do now is we're going to go value plus, and first I'm going to do right now up here, so I'm going to comment out that value so it doesn't pay any attention to it. Value plus, and I'm going to type in 3 letters, radians to degrees, yep, r. And I'll do this and I'll click there. And you'll see the arm has moved. Now it's moved because even though it should be pointing there, the angle that it starts at isn't at the top. The angle that radians start at is at 90 degrees. So I set that to 90 and it now points at that head. Now the thing is that we've got everything moving. Yeah, so if I now press play, look at that. It's always pointing at that piston head, and it doesn't matter where it is, which is the problem with lookAt. So if I take head, okay, and I'm just going to basically turn on the view options. Let's turn on all our controls so we can see what we're doing. I can take this head and I'm going to move it over here. Now you can see the arm is moving. Now what happens when I turn it and point it down there? It's still pointing at it. So it's not difficult mathematics at all. Let's just pop over here. Okay, look. It's always going to try and point at it. That's power of maths. There you go. You got a piston. Of course, then you can, if you want to, you can do better artwork and then just attach them to these, or you can just use it on the better artwork. But that is just the simplest way to make a piston. but in such a way that you can adjust it and all sorts of things. So at the moment, all that stuff is using time, that one time thing from here. So I want to very much quickly go down here like this, and I want to show you what I mean by doing a self-animation. So at the moment it's using time, so I want to create a new variable, but I'm going to actually put it on the arm. I'm going to go to Effects, Controls, and let's create a slider. So that just goes up and down, values all over the place. And I'm going to call it overtime. Why not? Who doesn't love overtime? And I'm going to go down here where I've got speed. I'm going to set the speed to 1 because we'll be doing speeds and stuff in here. So I'm going to go say overtime equals, and I'm going to very carefully drag with my little whip up to slider overtime, and it creates it, effect overtime slider, and there we go. So that's now in there, and as you can see, it's still using time here. So let's change this and let's get rid of time and put in overtime. There's nothing happening here, so let's put some values in here. Now these should be coming out as degrees, but I think let's just go to frame 100 and set this to 2 times pi, basically. So it's 3.14159. Okay, and so if we play this, yep, so if we play this, so let's make that 6.28 multiplied by 50. Okay, so now what happens is that in that period of time you get it doing it 50 times. It looks slightly insane. I'm going to move this all the way over so we get 50 loops over 1,000 frames, so it will now look a bit more realistic. There you go. Dum, 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 dum. And that, so there you kind of have it really. Let's just get this at the beginning. Let's set that to 0. Yep, there you go. So, you know, now what you've got basically is 2 expressions. One which makes the rod go X and Y in a lovely kind of way like that. Another one which just means it points always at the head of the piston. And then, you know, you've got control up here to speed it up or slow it down. Just so I'll explain that. This is a constant value that we've created, which is kind of like time, but it's not because it's adjustable. So I can put a keyframe in here. Let's just stick a keyframe in. Let's find our controller, which is over time. So we do that. So what I can do is I can take this controller, I can push this up, like this. Let's put another one in there. Let's put in a keyframe there, and then we can bring this down so it slows it down loads. And then we put this here and crank it up again so it goes up speed. So if I run this now, it's still using all the maths, but it's allowing with one variable for us to actually speed it up or slow it down. So you do have complete control over this. Also, if you want to, you can pre-comp this and then retime it in a second comp. And because it's maths, it actually does it beautifully and you'll never notice that it's been retimed. So anyway, there you go. I hope that's been of some use to you, and I hope you have enjoyed the tutorial. If you want any more of these, please don't hesitate to get in contact. I will be doing more anyway. But the next tutorial is about creating your own HDRI maps, and sometimes you can't find the one you want, and I'm going to show you how to build those in Blender. So take care, guys, and I'll see you on the next one.